brand strategy for Redwire, and I'd like to introduce to you all of our exciting panelists. We have Dean Bellamy, who's our Executive Vice President of National Security Space, Maureen O'Brien, who's our Senior Vice President of Engineering Solutions here, and we have Stan Kennedy, our Chief Architect for Redwire, and we have a special guest. We have Peter Klupar from Breakthrough Foundation, who's going to be giving some great industry insight. And I know that if there's anyone that can make digital engineering fun, it's definitely these guys. So I will turn it over to Dean.
Thank you, Terry. By the way, for everybody, if you want to follow the next social influencer on social media, it's at Terry Riley. You want to know what's going on in space, or you want to know what's going on at Redwire, at Terry Riley. It's the bomb. Awesome. Hey, everybody, thank you so much for joining us. It's a pleasure to have everybody here. I'd like to start by turning it over to Stan Kennedy. Stan, let's answer the most important question. What is digital engineering?
So, see if this is on. Is this on? Everybody can hear me? So I have no idea what digital engineering is. No, I'm just kidding. But before Pete and Andrew got me to take over the chief architect's job, Maureen and I were running one of the 7 companies that Redwire has acquired over the last year. And Redwire is completely committed to our digital engineering environment. We've been doing digital engineering for almost 9 years as the previous company, and even more years behind that. And there's a lot of hype on the floor on digital engineering, and there's very few tools out there that actually provide the framework for digital engineering. So to us, we actually had to take a step back and define the terms of reference so that when we do talk digital engineering, everybody was using the same lexicon and they weren't talking past each other. There are a lot of folks that say digital engineering and then they can't back it up with the tools, the framework, and the processes that go hand in hand with it. And digital engineering works if you still put the rigor of systems engineering into those practices. And so digital engineering to us is the ability to very rapidly compose systems of systems, be able to change those out early in the design cycle, and then have those digital engineering tools live throughout the life cycle. So we have a product over here called Acorn. It's really long name, but it's basically what its job is to be able to start out in an all-sim environment and then add capability to eventually generate out those digital twins. The big key, and Maureen's going to talk about this, is keeping your digital environment in lockstep with your actual physical environment. And a lot of people fall down with that. They start to rely too much on those digital engineering tools, and if they diverge, especially from a systems engineering perspective, you can tend to make mistakes with that. So Redwire has been fantastic in tying the rigor of configuration management, data management, with new space capabilities, with our tools, our API interfaces, and all of the products that go hand in hand with that.
So Stan, before I hand it to Maureen with a question, any big news or announcement we should talk about?
Just recently, in fact, right after the noon hour, Virgin Orbit announced that they're partnering with Redwire Space on their digital engineering environment. So we will be providing all of the digital engineering support for their advanced systems groups and all of the modeling and simulation that go with that. So we're very, very excited for that. And Maureen's group, Digital Engineering Solutions, is going to bring it home.
Congratulations to Redwire.
Woo, go Redwire.
All right, Maureen, a question that we all get asked. What is a digital twin? Can you describe that, and can you describe that for everybody, because the value of having a digital twin?
What do the kids call it these days? It's not an icon. I'm so old now. It's what is that thing called? Anyway, no. Digital twin. So we set up Acorn again with anomaly resolution, cyber, operating through in mind. We just set up a space lab for that very purpose, cyber resiliency. A digital twin, again, as Stan was saying, keeps you in lockstep with what your physical environment is doing. And if you start to diverge, your digital twin is hopefully there. It will be there to help you resolve where you're diverging, instead of, you know, a few years down the road figuring out that you just smacked into somebody or anything like that. So digital twinning is very important, but also is the cyber aspect. Anything digital, you got to bring cyber into play, right? So we've RMF'd our systems. We're coming under CMMC. So along with the DevSecOps for the life cycle, Acorn and the Cyber Resiliency Lab called HOSS. There's another press release out about that one too. We're really leading the charge to help keep the system safe and ensuring that they're working properly.
Thank you, Maureen. Pete, the big question with digital engineering is innovation. What type of innovation does it take? Can you describe the value of innovation to digital engineering?
Sure. Digital engineering has really enabled all the modern consumer electronics that we have today. But I'd actually like to talk about where Breakthrough is going to go. Breakthrough has a plan to send a probe to Alpha Centauri. So in order to do that, how are you going to build a spaceship to go to another star? Well, we have about 5 teams right now working mostly at universities like Caltech and MIT and those places to develop a means to be able to print digital circuits, active and passive digital circuits on top of thin films. So 400 atom thick sails, and we're going to use that as the substrate to print the digital components on. And we think that can actually work. So it does sound like science fiction, but within about the next 2 or 3 years, we're going to have actually built prototypes of this, and probably within 5 years, you'll see them launched and flown. And hopefully Redwire will be a part of that. We'll see.
Can I jump on that?
Go ahead, Stan.
Yeah, Pete's vision and Pete Warden's vision for Breakthrough is being enabled by things like the on-orbit servicing and manufacturing technologies that Redwire is providing. But the ability to actually forecast and then be able to build on your way to Alpha Centauri, that's pretty cool. And so I think getting the right environment and then being able to keep up with how do we keep the actual physical system and the digital system tied together is going to be critical for that long-term success. And then also passing that information on to the next generation and the next generation, because it takes a long time to get there.
Thanks, Pete. Thanks, Dan. So the question I've been asked by everybody is why now? Why are we talking digital engineering? So Maureen, I'll hand it to you first, and then we'll go down the line.
Well, Microsoft Excel is really hard. A number of us have done, spreadsheets upon spreadsheets upon spreadsheets, and this brings it home and ties it together. From our perspective, it's, there are so many disparate technologies out there, and they all need to talk to one another. I mean, we are in a cost-constrained environment for a very long time. There's not infinite amounts of money, and we need to find a way to have everything work smartly together. And that's where we focused mainly with our bridges, is to tie those things together so they work with one another. If technologies are gonna stay in their homes with the IP protections, etc., but let's tie them together and make them work together so that we can all move forward and do great things in space.
By having APIs or common interfaces and standards, you're able to swap in and out third-party software, and you're able to continue to innovate as new products come out. You're able to continue to drive innovation rapidly. All right, Stan, why now?
So I'm gonna take it a little different direction. So we're doing a lot of work right now in hybrid architectures and mesh networks, and think about Space Development Agency, and they're going to buy 150 satellites from 5 different providers. Those 5 different providers are all going to have to talk a common BMC3 interface, and all of those different layers are going to have to interface and talk together. If you don't have standards and if you don't have interface compatibility, that's a bad day. But B, you have to be able to then, you can't build enough EDUs and flight units to be able to send those out to all of the organizations to be able to cost effectively implement those systems. And the disparate system part is even more important, because as we start going across commercial, coalition, US, as we start going against joint all-domain operations, where you're tying air, land, sea, maritime, cyber all together with space, you have to have those bridge structures to be able to make that happen. And you have to be able to design them so that you have information, or excuse me, domain space. So think about space and cyber and air, land from a JADC2 perspective, and information decision space, and be able to do high fidelity modeling and simulation of those systems.
All right, Pete.
I guess from a customer's standpoint, why would I want to be limited by just what one company invests? Why can't I take advantage of what the Air Force invests in, what the Space Force invests in, what the Europeans invest in? I mean, the commercial world dwarfs the DoD space world. And so why can't I get to a point where I'm utilizing their capabilities, trying to take it, I guess, try to take advantage of it, but you don't want to say take advantage. I don't know. Best in class.
Best in class, right? You always want to have the best. All right, so I have another tough question for our panelists. Use cases. Let's describe a few use cases of digital engineering for our audience.
Don't spend all the money up front. Right? Optimize your system. You know, build simulations, emulations before you go out and buy millions upon millions of dollars of hardware and then find out that it doesn't work together. Test the interfaces, test the interoperability, and figure out what's going to work best for your mission versus, you know, what spacecraft is being pushed upon you or what have you. Figure out what you need and be a smart buyer and a smart innovator.
I'm going to write a standard interface for the delay in these microphones, but I think the killer app for digital engineering is really, there's many, but being able to very rapidly tie disparate systems together in a high fidelity environment, and the amounts of data that are getting generated right now lend themselves to being able to then operate on that for information. So we have great systems in the commercial world, in the DoD, in the IC world, in the coalition world. They're not fully utilized because a lot of the data is falling on the floor. So the first step is digital engineering and digital twinning, and then as you generate those data sets out, being able to operate on them with machine-to-machine data sharing, electronic ICDs, and then also allowing those human-assisted decision points with an AI asset. That's where those use cases are going to pay dividend.
So absolutely, having the automation, the artificial intelligence, and machine learning is really critical. Pete?
Well, my use cases are more science fiction based than, but reality. Going to places like Venus, Europa, Enceladus, right? My use case is actually utilizing the digital electronics, and the only way to do that is to have something that's very light, very complex, very capable.
Right. I'm also going to remind people the #1 space social influencer is at Terry Riley. All right. We now want to ask the crowd, does anybody have a question for the panelists? Anybody have a question? All right, we do. Hey, at Terry Riley, right here, we have a question.
Test, test.
Thanks for putting this presentation on. Digital engineering is full of white space. What are the biggest gaps that you see that need to be closed in order to accomplish your journey?
So the question is, there's a lot of white space out there, and where are the gaps? I think the biggest gap I see right now a lot of people say digital engineering, and then they don't understand that there's policy enablers, there's tech enablers that go along with it, and you have to tie all of those things together. Where I think the gaps are right now is in configuration management, data management. We tend to get enamored with a cool digital tool, and then people make changes to the physical system, and we have a divergence. And I'm an old guy, it doesn't show with the mask and everything, but there used to be these really good systems engineers that would make sure that everything tied back to the system requirements or the mission requirements. So mission effectiveness, mission performance. If you rely on your digital tools as gospel, you will get in trouble. You need to every now and then tie that back to physics and tie it back to the actual physical world. And if you don't, it tends to give you some backside scar tissue.
Stan, I would add to that, the model-based systems engineering, having that embedded in there is a really critical aspect as well. I will look at the crowd. We have this large crowd here. Any questions for the panelists, to the folks here at the Space Symposium on digital engineering?
We have tons of time.
Okay, I have a question. Go ahead,
Oh,
Stan.
you got a question? I got a question for the audience. Raise your hand if your organization does digital engineering today. Okay? Now, of all those people that do digital engineering today, have you seen any gaps in your digital engineering end-to-end configuration? Keep those hands up.
Be any Redwire hands up. I'm just going to tell you that right now.
Right, I kind of want to do a final little discussion with the team here. And so what I'll do is, let's all have our kind of final thoughts that you'd want to share with everybody about digital engineering. So Maureen, let's start with Pete. Pete, any final thoughts or any final comments you want to say about digital engineering?
Yeah, I think the focus needs to be on driving the cost down. How can we enable more missions by driving the cost into a more affordable, even though it's really cheap now, it's probably an order of magnitude cheaper than it used to be, maybe 2, but it still has a ways to go. So stay focused on cost.
So I'll piggyback on that, but take a little bit different tact. Keeping the cost down is super important. It's interesting because a lot of people come and say, I want to buy a whole bunch of hardware in the loop labs. And I think that with where virtualization is going and containerization and a lot of the capacity that is out there now from a production capability, from a processing capability, you need to tie back to those physical systems, but you need onesie twosies of those. I mean, back in the day, we never had enough EDUs, we never had enough flight units. What we're finding now is if you can get a really good high fidelity simulation emulation that ties back to what's sitting in your one high fidelity hardware in the loop lab and keep that system consistent as you go through the life cycle, not only are you faster at it, but I think you reduce the costs overall because hardware is expensive. Processing time is inexpensive. The issue is you've got to make sure that that processing data and information that comes out is physics-based and it stays consistent throughout the life cycle. So, I mean, mind your P's and Q's and stay on track, but you also got to tie it back to why are we here from a mission performance, mission effectiveness perspective.
And to that point, as blocks of satellites are coming out, if you have the digital model and you want to add rapid innovation into it, by having that model, you're able to add schedule speed, lower technical risk, and actually reduce costs immensely.
I think even more importantly, you get rid of obsolescence. When we were doing programs in the past, if you'd invested $6 million, $8 million, $10 million in your flight software and it only targeted one processor, that's a bad day when the processor guys say, yeah, I used to charge you $1 million, now I want to charge you $4 million. You were pretty much stuck with your sunk costs. Digital engineering allows you to be agnostic to the supply chain, and you obfuscate the need for being reliant on an obsolescent part or a piece. So case in point, we had a customer come to us and ask us to incorporate a thermal model into our Acorn product. And we actually told them no. We don't need to do that. We write an EICD out to thermal tools like Veritrex, which is a Redwire load path product, or a thermal desktop, or Aura, and they do that job very well, and then you're not dependent on this Battlestar Galactica model. It's a framework that ties all of those systems together, and it keeps your costs down.
Absolutely. Thanks, Stan. Maureen?
I think along the lines of innovation, I think this is a great way for folks to exercise their tech roadmaps. The on and off ramps, and ensuring that what you're out there looking for is going to work within the system, or how can it be made better to work within your system. I also would say, along the lines of what Stan said previously, any tool is only as good as the user. So checking back with the requirements and the actual physics of the whole thing is very important. We don't want to become completely reliant on just tools. Just like sailors still need to learn how to read the stars, we still need to know how to work Excel and make those giant formulas every now and then, and double check ourselves.
I would like to end with talking about mission, right? So everybody knows now that space is a warfighting domain. And when you look at the United States, we love to go partner with our coalition allies and friends working together. And I believe that there is a huge advantage to having digital engineering to be able to really, I would say, when you agree, Stan, to be able to have geographically separated people being able to work together. And you've actually done that, haven't you? Distributed architecture?
Yeah, part of the Hyperion Operational Space Simulation Lab, the HOS lab, is the geographically dispersed and organizationally dispersed capabilities. The virtualization side of that, and the ability to do that across continent and across multi-mission partner domains is very, very important. I also think that it's interesting because I think over time you're going to see a convergence. We're sitting right next to the NASA booth. NASA's doing cislunar, NASA's doing lunar landers, they're doing Gateway, they're doing a whole bunch of stuff. U.S. Space Force is starting to work into the Geo Plus and cislunar activities, being able to effectively tie the three things that make it possible are vehicle dynamic, network, and communications. And if you can tie those three things together in a digital environment, and then be able to do the cross NASA, cross DoD, cross IC, cross coalition, not only does it help enable the deep space missions that Pete's working on, but allows us to continue to protect, our transit and think of the high seas of the deep space environment. It allows the folks to coexist out there.
And getting back to coalitions, it's a great way to partner with our friends from other allied countries, right? And it's a great way for them to all work together with either the Space Force, NASA, other civil DoD commercial partners.
Did I mention that Acorn is Commerce Control List so that you can sell that internationally?
I didn't hear you say that. Awesome. We really want to thank everyone today for taking the time to join us for this Tech Talk. We really appreciate it a lot. Once again, Stan, congrats to you and Maureen on the great news today with that came out in the press release. So maybe you could, Maureen, why don't you tell everybody as we walk out off the stage some of the great news we got today?
just again to reiterate, go Redwire and go Virgin. We're teammates and we're going to make it happen.
Terry, anything else?
Check. Thank you, everybody. Thank you again to all the panelists. Thank you, Peter, for joining us. Really appreciate that insight. Join us tomorrow. From tomorrow on to Thursday, we will have happy hour here starting at 3:30, followed by a tech talk at 4 o'clock. And tomorrow's tech talk will be with Firefly. So please make sure to come back. And if you're on the live stream, be sure to follow at Redwire Space for continuous live updates throughout the event. Oh, we have a... Oh, you're just waving. Okay. All right. All right. Thank you, everybody. Have a great day.